So law of sines doesn't work for every single triangle. Sometimes we need the law of cosines. So the law of cosines looks a lot more complicated than the law of sines. You've got all of these three equations down here. But I want to break them down for you so that they don't seem so bad. So first of all, the lowercase letters still stand for sides, and the uppercase letters still stand for angles. So let's just take that top row. Notice that the very beginning of it, the way it starts off, looks like Pythagorean theorem. So that's one thing to notice. Another thing to notice that little side A starts us off, and angle A wraps it up. It's the same for all three of these forms. If little side B is by itself, then we're using cosine B. If little side C is by itself, then we're using cosine C. Also notice in that top row, the only place angle or side A gets used is on that left-hand side. It's sides B and C that show up in the other slots. So we use law of cosines when we're working with a triangle in which we know either all three side lengths, we would call that the side case, kind of like in geometry when we think about the three sides of a triangle being congruent to the three sides of another triangle. Or we use it when we have two side lengths and the angle between them, the side angle side case. Again, just like geometry. In other words, if we knew, say, this was 3 and that was 5 and that was 30, that's side angle side because we have two sides and the angle that's between the two sides, like side angle side. However, we would not have it side angle side if we had 3, 5, and then 30, because then we have side, the angle should be here, but it's not. It's a side angle, and that's when we would use law of sines. So if it's not side, or side angle side, you want to use law of sines. Okay, so let's use law of cosines to find the missing side. So first we're going to set it up. So I see that I know angle B, and I'm looking for side B. So I'm setting up B squared equals A squared plus C squared minus 2AC cosine B. And no, I'm not going to make you memorize the law of cosines. Okay, so I'm going to plug in. So I don't know B squared, but I know A squared is 25. So 25 squared plus 20 squared minus 2 times 25 times 20 cosine 34. Remember, it's a times sign in between there, the 20 and the cosine 34. Now that might look overwhelming, but notice there are no variables on the right-hand side. So all we have to do is go to our calculator and just plug those numbers in. So let's do that. So that's 25 squared plus 20 squared minus 2 times 25 times 20 cosine 34. And so we get that B squared is just about 195.96. And we'll take a square root of both sides to see that we have that B is just about 13.998. If I were to round that to the nearest tenth, that would be 14. So B is just about 14 using the law of cosines. So now let's look at finding a missing angle. It's really not much more complicated. I mean, it's a little more complicated, but there's a common mistake people make that I want to steer you away from. So we're looking for the measure of angle A, which means that I want the form of law of cosine that starts with A squared equals B squared plus C squared minus 2BC cosine A. Okay, so I know I have 11.4 squared equals 9.4 squared plus 14.7 squared minus 2 times 9.4 times 14.7 times the cosine of A. Now, what I don't want you to do is to say, well, I'll just take my calculator and I will just put all these numbers into it and get it down to one number times the cosine of A. There's an issue with that. I'm going to take this step by step this time and see if you can spot what the issue is with that. Okay, so let's bring out the calculator and see what we can do here. So let's just get some let's figure out some things. So 11.4 squared is going to be 129.96. And then we need to know 9.4 squared, and that's 88.36 plus. Then I need 14.7 squared, and that's 216.09. And now I'm going to do 2 times 9.4 times 14.7, and that's 276.36 cosine A. Okay, so you might recognize now why I can't put the whole right-hand side together. And the reason I can't is because this is being multiplied by cosine A. So by order of operations, I've got to sort of unwind until I can get there. So I'm just going to take it a step at a time here, and I'm going to add these two together. So that's 88.36 plus 216.09, and that's 304.45 minus 276.36 cosine A. Are you always going to write all these steps out? No. Just thought I'd do it this time. So let's subtract that 304.45 from both sides. So let's see, that's 129.96 minus that 304.45, and I have negative 174.49. That's okay. And that equals negative 276.36 cosine A. We're almost there, but I've got to get rid of that coefficient of cosine A. So we have to divide by negative 276.36 on both sides. Okay, so let's see. Divided by negative 276.36. And so I have that 0.631 is about the cosine of A. So I need to do inverse cosine on both sides to get A by itself. So let's see. So inverse cosine of the answer that I just had. So I have that A is just about 50.8 degrees.